Hello everyone. Today we are going to discuss about the control unit. Control unit generate control using any one of organization, whether it is hardwired control unit or microprogram control unit. Now we will discuss about the hardwired control unit. In the hardwired control unit, the control logic is implemented. The control logic is implemented using flip-flop, logic gate, and or not, etc. And encoder, decoder, and other digital logic circuit. Basic, Basically, overall the conclusion, as the name also suggests, the hardwired, like it is overall the control signals or the control unit is implemented with hardware. Now we are going to discuss about the block diagram of hardwired control. Okay, is the control unit which is implemented using a combinational circuit. Now we will discuss about the input that are coming in the control unit. First input is from the instruction register. In the instruction register, the instruction is retrieved from the memory. The instruction in the instruction register get decoded using instruction decoder. Then after come to control unit. And the second input is from the system bus. Third input is from the flag. And the fourth input is from the clock. And the fourth input is from the clock. All the set of four inputs, that is, first is from the instruction register, and second one is from the system bus, from the flag, and from the clock. These transform them into the set of the control signals, which then go to the register, bus, and ALUs, that is arithmetic logical unit. This is used for the operation of mathematics operations like addition, subtraction, etc. Okay, after the execution of each instruction, end signal is generated. This reset signal, which reset the control sequence counter and make it ready for generation of the next instruction. Overall, get the summary from of the block diagram of the hardware control unit. It's take the input from the instruction register, from the system bus, from the flag, and from the clock. And combining these, it generate the control signals which go to the register bus ALUs. And after the execution of the each instruction, end signals is generated. This reset the control sequence counter and make it easy or make it ready for the generation of control sequence for the next instruction T0 to Tn minus 1. Hardware control unit are generally faster and simpler in design, but they are less flexible and more difficult to update and modify. The risk, that is reduced instruction set computer, are implemented using a hardware control unit. Now we are going to discuss about the advantage of the hardware control unit. It is very fast because it is implemented using a combinational circuit. And also, as we further discuss, risk is also implemented using a hardware control unit. Now we are going to cover the disadvantage of the hardware control unit, that it is a difficult to design and modify. Instruction set and the control logic are tied together by a special circuit. Or in the simpler way, we can say that it is difficult to modify if there is a new features we want to add. So we cannot easily modify it. Now we are going to discuss about the hardware control unit of a basic computer. Here is the instruction register of the 16-bit. First 1 bit is for mode. First 0 to 11 bit is for address. 12 to 14 is for operand. And mode, and 15 is the mode. Here's the 0 to 16 bit. Okay, is the control logic gate. Now we are going to discuss about the inputs that are going to control logic gate. First is input from here, address of this, and the operand, which operation we have to perform, whether it is a multiplication, addition, subtraction, or anything. That is mathematical operation or logical operation what we have to perform. Here we use a 3 into 8 decoder. From D7 to D0. Through the 3 into 8 decoder, the operands get generated like 000, 001, 101, 011, 100, 101, 110, and 111. These 8 signals will generated or from the 3 into 8 decoder. And 15, that is last, that is a mode, is passes through the flip-flop, and this is denoted by the symbol I. Then after the last signals, that is signals of the timing pulses, is from T0 to T15, which is generated using a 4 into 16 decoder. The first the first 12 bit are applied to the control logic. 4-bit sequence counter can count from 0 to 15 in binary. Its output is decoded into the 16 pulses 0 to 15 using a 4 into 16 decoder from T0 to T15. The sequence counter is implemented by the INR, that is increment, and CLR, that is clear, and third one is a clock. The INR input and the clear input, the sequence counter is incremented by the INR and clear by the CLR input synchronously. Now we are going to discuss about the microprogram control unit. Here the signals or the control logic is implemented using a programming approach. Here the control signal or the control information is stored in a control memory, and this control memory is programmed using a programming approach to initiate the required sequence of the micro operations. Required sequence of micro operation. Overall, if we talk about the structure of the control memory, it contains a microprogram, and microprogram is the collection of the micro instruction. Thus specify the sequence of the micro operations. The control signals in the control memory is stored in the form of binary, that is 0 and 1, as a control word in a ROM chip, which is called a control memory. Each control word in a control memory is contain the micro instruction, and each micro instruction specify one or more micro operation for the system, and the collection of the micro instruction is called the microprogram. Like these are the micro instruction, and from here it is a micro operations, and here's the collection of the micro instruction is called the microprogram. The control memory is assumed to be ROM, that is read only memory, within which all the control information is permanently stored. Control information means that is a 0 and 1 control words, etc. And the address where these micro instructions are stored in the control memory is generated by the microprogram sequencer with the help of the IR, that is instruction register. If we talk about the overall structure of the control memory, here is the control memory, ROM, that is read only memory. Micro instruction, and micro instruction. This collection of the micro instruction is called the microprogram, and this is a control word which is only in the binary 0 and 1, and each micro instruction form micro operation for the system. Here's the overall structure. If we talk about the control, if you talk about the microprogramming control unit, here's the control memory, ROM, microprogram, collection of the micro instruction, and in the micro instruction is a collection of the consist of control word which is only written in the binary, that is 0 and 1. After that is divided into the macro operations. And if we talk about the task that is performed by the microprogram control unit, first is the micro instruction sequencing. It will sequence the micro instruction which after which is going to execute, and then after micro instruction execution, it also execute the micro instruction. And the micro sequencer, the other work of the micro sequencer is generate the address of the micro instruction according to the instruction stored in the IR. All possible control words are stored in the memory, that is control memory, and based on the requirement the specific control word is fetched from the memory. Now we are going to discuss about the microprogram control unit block diagram. Here is the first is the next address generator, or microprogram sequencer. This determines the next address from within the control memory, and this take input from the external input, any clock input, and from the instruction register. Okay, then after is the control address register. Like if we talk about the normal program where the PC, program counter, which refer to the next instruction to be performed. Here is the CAR, or called the micro PC. It contains the address of the next micro instruction to be executed. Contain the next address. Contain the address of next micro instruction to be executed. To be executed. Then after, control memory, where actually the micro instruction or the stored, as we earlier discussed about, also referred as the ROM, that is the read only memory. Then after is the control data register, CDR. Control data register, CDR, which execute the micro instruction, or contains the micro instruction to be executed. It contains the micro instruction to be executed. Then the control words is passed through the decoder. Control word decoded using a decoder. Some output signals is control signals go to the CPU, and some to the system bus. After that, next address information is passed through the microprogram sequencer for the execution of the next address information, instruction. Now, we're talking about the advantage of microprogram control unit. The design of the microprogram control unit is simpler, less complex, because microprograms are implemented using a software routine. It is a less complex. It is a cheaper and less error prone to implement. It is a more flexible than hardwired control unit. Hardwired control unit is not a flexible. It is a flexible because of the design, modification, correction, and enhancement. All of these are easily possible in microprogram control unit. Now, and third one is the new or the modified instruction set of CPU can be easily implemented by simply rewriting or modifying the content of the control memory. Basically, if we compare the hardware control unit and the microprogram control unit, the way it was a disadvantage in the hardware control unit, which is the advantage in microprogram control unit. Like, it modify, if there is a new modified instruction from the CPU, it easily implemented by rewriting the control word. Or the memory of the control memory, that's the consist of the control word. And complex functions such as a floating point number, can be realized efficiently. CISC, that is Complex Instruction Set Computer. Instruction set computer are implemented using microprogram control unit. Microprogram control unit. Now, if we talk about the disadvantage of the microprogram, the microprogram control is slower than the hardwired control unit. The reason behind is the time required to access the micro instruction from the control memory. कंट्रोल मेमोरी से जो माइक्रो इंस्ट्रक्शन को फेच करना होता है उसके लिए टाइम बेसिकली देयर इज़ अ टाइम इशू. And if we talk about the flexibility, which is also achieved by some extra hardware, and the flexibility is achieved at some extra hardware cost due to control memory. If we all over the summarize the differences of the hardwired and the microprogram control unit, here is that. First, if we talk about the speed. Speed in the hardware control unit is fast because it is implemented using a combinational circuit, and here is the slow because we have to refer control memory for the instruction. So here's the time issue, that's why it is slow in the speed. And if we talk about the implementation, hardware is implemented using a hardware like a flip-flop, decoder, encoder, and other digital logic circuit, whereas microprogram is implemented using a software. It is using a programming approach. For control signal, for generation of the control signal. And cost of implementation. The cost for implementing hardware is more, where microprogramming control unit is cheaper. And if we talk about the flexibility, it is not a flexible but difficult to modify for the new instruction set. It is flexible, and new instruction set can be easily modified by rewriting the control memory. The control memory. Okay. Ability to handle the complex instruction set is difficult here and it is easier here. And decoding in the hardware control programming is complex, whereas in microprogram control unit is easy. The control memory is absent here, is absent in hardware control unit, whereas it is present in microprogram control unit. If we talk about the application, CISC RISC microprocessor are implemented using a hardware control unit, and CISC is implemented using a microprogram control unit. If we talk about the instruction set size in the hardware is small, whereas in the microprogram control unit it's a large. And the design process in the hardware control unit is difficult and it is easier in microprogram control unit. Chip area required. In the hardware control unit, the chip area required is less, whereas in the microprogram control unit, it is more. Thank you.